This is episode 5 under Mathematics Universe. In this episode, we will discuss about how to find the sum of even Fibonacci numbers. First, let us understand what is meant by Fibonacci numbers. And in the screen, I have clearly wrote the first few Fibonacci numbers starting from 0 followed by 1, 1, 2, 3, 5, 8, 13 and so on. And what is this Fibonacci number is all about? For example, let us take 10th Fibonacci number f10. We arrive at f10 by adding f9 and f8. So f10 is equal to f9 plus f8, which means we got that 55. And what's f9? 34. And what's f8? 21. By adding the 34 and 29, we landed in 55. Very similarly, if we want f6, then what we should be doing? Find f5 and then add it with f4. So what is f6 is? f6 is 8. And how we arrived at 8? By taking f5, which is 5, and then add it with f4, which is 3. So 5 plus 3, we landed in 8. So taking these two equations and we can generalize them, and we can get a formula fn is equal to fn minus 1 plus fn minus 2, and this is a generalized formula for Fibonacci number. So if we want any nth Fibonacci number, then we have to find n minus 1th Fibonacci number and add it with n minus 2 Fibonacci number. Fine. So this is how the series is made up. But the question is, how to find the sum of even Fibonacci number? Two approaches we will see. First approach is, let us generate all the Fibonacci numbers and then find with condition which one is even and then just simply add them. We will take all the Fibonacci numbers and then filter the even Fibonacci number and then just simply add them. That's the first very simple approach, and we will see how to do that. For example, the first two Fibonacci numbers, the first Fibonacci number is 0. I'll take a equal to 0. And the second Fibonacci number is b, and let me take b is equal to 1. And starting from here, how to find the third Fibonacci number? To find the third, the next Fibonacci number. So this is basically f0 and this is basically f1. And now to find f2 using a variable c, what we have to do? We have to add the two previous numbers, add the two previous Fibonacci number. So which means we will have to add a and b to get the next Fibonacci number c. So which means c equal to 0 plus 1 equal to 1. So we got the next Fibonacci number. Now, is it an even number? No, it's not an even number. So we will also take a variable sum and just set it to 0. Whenever we encounter an even Fibonacci number, let's add it to sum. And initially 0 and 1 are not even Fibonacci numbers, so let's not worry about it. But the next even Fibonacci number that we are obtaining is also 1, which is also not an even number, so we cannot add it. And what is the next step? Now this b value should become your new a value. So a will be equal to 1. So b value is transferred to a, and this c value will be transferred to b. So b will also be equal to 1 now because c is 1. What is generally happening? Generally 0, 1, 1. 0 is the value of a, 1 is the value of b. Adding both of them, you got c. Now after generating c, you want to generate the next term. If you want to generate the next term, then you have to add these two numbers to generate. So because of that, we are making this our new a and we are making this our new b, so that the same formula can be reapplied again. Now again a plus b will be 1 plus 1, the next value will be 2. Now again make this 1 to be your a and make this to your b and add them to get the next value, which is 3. Make this your a and make this your b and just add both of them to get the next Fibonacci number, which is 5. So similarly, we can proceed further. So let me just write a very quick loop to generate all the Fibonacci number. First, we will just pick A and then just set it to 0, and we will then take B and just set it to 1, initial values. Now initially I will take just simply C and just simply I'll set it to 1. Okay, initially I'm just setting just C equal to 1. Now let me assume that n is equal to 10, for example. I want to generate all the Fibonacci number under 10. I can just simply take a loop, and in the loop I will just put a condition that C is less than or equal to n. So using the variable C, we are generating the next term in the Fibonacci number. So C will be the new Fibonacci number. C will always be the new Fibonacci number, and that new Fibonacci number, if it is less than or equal to n, we will continue, but if it exceeds n, we will stop. So the first Fibonacci number is A, the second Fibonacci number is B, and the next Fibonacci number, the new Fibonacci number, will be C. So coming into the loop, what is the first thing we will do? I will take C equal to A plus B. At the moment, whatever the value of A and B, add that, you will get the next term in the Fibonacci number, and that's going to be C. But after calculating it, transfer your B value to A and transfer your C value to B. And once after transferring it, again this loop will again work and this formula will be again executed. So the new A value, new B value will be added to again generate the new. For example, let's take first few Fibonacci numbers, and let me assume the first 0, that is F0, to be A, and let me take 1 to be B, first two Fibonacci number. Now just simply add this A and B to get the next Fibonacci number C. You add these two numbers to get C. Now what you do is that you make your F1 to be your new A, that is you make your B to be your A and you make your C to be your B, and adding both of them you will get the next Fibonacci number. Repeat the process again. You make this B as your new A and you make your C as your new B, add both of them to get the next Fibonacci number. Let me repeat again. Let us do the same thing again. Let's take this B as A and let's make the C as B, then add this to make the next Fibonacci number, to find the next Fibonacci number C. Again you take this B to be your A, C to be your B, and then add this to get your next Fibonacci number, and this keeps going. So where is this A value and B value starting from? It starts from 0 and 1. So can we just initially take A equal to 0 and then B equal to 1? Then after that what we are doing? We are repeating the same steps again and again. Like we will get C by adding A plus B. So the first procedure is C equal to A plus B. And after obtaining the next term, what is the next thing that we were doing? We were making our B into A and we were making our C into B. So what's the line for that? A equal to B and B equal to C. So I made my B as the new A and we made C as our new B. And after doing that, what we have to do? Add both of them to get the next Fibonacci number C. So which means, can I say this formula has to be again executed? Now what after that formula? After that formula, again you make your B as your new A, C as your new B, and again proceed with adding both of them to make it C. So which means, can we say that these three steps are being repeated again and again to keep finding the next term in the Fibonacci series? So to repeat these three lines again and again, let me just put it inside a curly braces and just put a loop outside it. So let us place this three lines inside a loop so that these three lines will repeat up to the newly generated C, that is the newly generated C value should be less than or equal to a certain n. Maybe my n is equal to 10. What will happen? This loop will generate all the Fibonacci number up to 10. But see, Above the loop there is no C, right? So we will just, for example, we will take the variable C and just we will assign it to 1, just some random value we are just assigning it. And initially, since the C will be, like if the C is less than or equal to 10, we will continue inside and we will just repeat this 3 steps. And whenever this step is over, you have your new Fibonacci number in the variable C. So what we can do here to find the even Fibonacci number, after finding C, this particular line, we can include a condition that if C modulus 2 equal to 0, for checking whether the newly generated Fibonacci number is an even number or not. If it is even, let us just simply add it to a variable called as sum. So sum is equal to sum plus C, whereas initially we can take sum and set it to 0. So this is one very simple way of finding the sum of even Fibonacci number. We have to find the sum of even Fibonacci number up to this received n value. So first we will write a function, okay, and the return type of the function, let me take it as integer, and the name of the function I will take it as sum underscore EF, even Fibonacci number, and in the parameter we will also pass the value of n. So now coming inside this function, step number 1, as we saw in the approach, first we will take a variable called as a and set it to 0, and we will take the variable b and set it to 1, and also we will take variable c and just set it to 1 initially. And now we will write a loop while, and c is going to be the next Fibonacci number, and let's check whether that c value is less than or equal to n. So if c is less than or equal to n, we go inside and there is 3 steps which we were repeating again and again. And what is those 3 lines? C equal to a plus b, then we are transferring the value of b to a, so a equal to b, then we are transferring value of c to b, so we have to write b equal to c. Now the very important thing is, first we will have to take a variable called as sum and just set it to 0 outside the loop. And once you calculate c, which is the next Fibonacci number, then just check whether that Fibonacci number is an even number. Suppose if that Fibonacci is an even number, then just simply add it to sum. So sum is equal to sum plus c. So you generate the next Fibonacci number by adding a and b, and just check whether that new Fibonacci number is an even or not. If it is an even, then just simply add it to sum, and then transfer the value of b to a, transfer the value of b to c to b, and then keep just repeating this process up to your c reaches your n. Once your c crosses your n, stop the process. And finally, when you come out of the loop, you have your final answer in the variable sum, which you just simply written. Now coming to the main function, we will go with just cout double less than, and just simply call this function sum underscore ef, and then just simply pass n. We are just displaying the answer. Now let's compile this and just proceed with the execution. Now we will just start giving 10. So when we give 10, what should happen? All the Fibonacci number, even Fibonacci number below 10 has to be summed. There are 2 even Fibonacci number we have below 10. One is 2, the other one is 8. So when we add both of them, we will get 10 as the answer exactly. What if we try with, okay, maybe 50? So if you take 50, there are 3 even Fibonacci number, 2, 8 and then 34. So 2 plus 8, 10, 10 plus 34 will be 44, and let's check. Yes, 44, correct. So this is absolutely working fine, and it's a very simple approach. We keep generating all the Fibonacci number, and while we generate the Fibonacci number, we are checking whether it is even or not. If it is even, we are adding it cumulatively to a variable sum. And finally, when the C value exceeds the n, we stop and we simply return the sum value. But this is not very efficient for calculating the sum of even Fibonacci number. There is a much more optimized way which we will discuss in the next episode.